Technology for the sake of technology is meaningless, at least to the enterprise corporation. And you're going to be faced with that question from every manager: why do we need this? And why is such an important question when we get into the network world. It precedes any definition of how that I can give you. For example, if you go into my garage, you'll find out very quickly that I'm not a real handyman. I have one of those tool chests with all kinds of tools. And if you open them up, half of the tools that are in there, I really have no idea what they do. And if someone were to ask me, well, what's that do? I would say, pick up stuff. You know, because most of them have handles that can squeeze stuff and have some long, skinny thing on it. And I would say, well, that I can pick up stuff with that. And they'd say, well, what's that do? Well, I can pick up other stuff. Well, why do you need all this stuff to pick up stuff? I don't know. It just ended up in my tool chest. And in the same way, when you get into the network world, you're going to see routers with all these interfaces and switches. And you first have to answer the question, why do you need all this stuff? What do these interfaces do? What do they connect to? What is it used for? And that is the question that we're going to drive at through this video. What is a network? And the subtitle I have, or the subsection for this whole group of videos, well, two of them, big group, two of them is foundations. And these next two videos, this and the following video, will lay the foundation for the entire series, meaning everything that we say for the rest of the series, and let me be brave and throw out there, for the rest of your Cisco career, is going to be built on these two videos. Why do we have a network? Why are we putting all this stuff on here? Why is this company spending hundreds of thousands of dollars just to bring in network equipment? That's what we're here to answer. Number one, function of a network. Number two, the pieces that make the network tick. Number three, the applications that use network. And I would say that's a pretty big one, because that's when you start getting to the return on investment question. Why should I spend $100,000 for this? What will I get back? Finally, we'll look at some network designs of how all these pieces fit together. What is a network? That's the question I tried to answer when I created the slide. And it turned out to be a lot more difficult than I thought it'd be, because, you know, I thought, okay, well, we need to start this video off by describing what a network is. And immediately this picture came to my mind. I thought, I'll put a couple buildings on there, a cloud, get some lightning bolts. You know, we've got our mobile user right there kind of hovering from the cloud. You know, everybody's connected together, and I put it together almost with that Bob Ross painting sense, and I said, voila, there it is. That is a network. But then I started thinking, well, how do I describe it? How do I describe it without using the word thing or stuff? It was difficult, because I thought, well, things plug into there and do stuff. That was one of the toughest things for me, is I want to move into what the network does for us rather than what the network actually is. So I almost had to regress my mind some thousands of years back to the day when we had kings that would send messages by horses, and they would say, I have a proclamation to send to my loyal subjects, and stamp that letter with their seal, give it to the horseman, and he would run across all these roads and deliver it to the people and say, hello, you must pay this number of gold pieces to the king, and you'd have an uproar. But the function of all that is what we focus on. You see what I just did? I just described the king putting the stamp on the letter and the horseman going across and delivering a message, but that is an application that runs across the network. Do you know what the network is? The roads. The roads the horsemen used to reach those people. Everybody said Rome was so great. You know, Rome, one of the first major world-conquering civilizations. Why was Rome great? Because they built roads, because they built ways to get to places. That is what the network is. We have to think below the application. We have to go below the uses for the network to think of the actual roads. Now, don't worry, but let me mention, you're going to spend your entire Cisco career building roads. And I know you might be thinking, well, that's boring. Why did I sign up for this? Well, trust me, there's a lot you can do with roads, and there's a lot of ways to engineer these roads to be, well, see, now I'm going to start getting into the uses of the roads, but I'm telling you, it's exciting to build roads, but that's really what the network is. So the way I can describe it is the fabric. I guess that's my modern definition of roads that ties business applications together so that the devices that plug into that and can reach those roads can communicate together. Now, before we get into understanding the pieces of the network, I've got to reassure you one more time, Cisco is far more exciting than building roads. It just felt really bad after that last little piece there. I was thinking, I hope I just didn't ruin the entire Cisco career because people are thinking, I didn't sign up to build roads. Trust me, it's much cooler than building roads, and you'll need to understand the network applications that run on top of the roads to be able to successfully engineer the roads in the right way and firewalls. And I'm telling you, this is the coolest career you will ever have. Period. All right. Understanding the pieces of the network. This is if we were to zoom in to that headquarters building. You see it up there in the upper left-hand corner, and look at a typical network environment and see what's inside of that building running it. Now, of course, we have our standard PCs, our user workstations, and those could be just some Dell computers or some Apple computers that you have running there, and they're running the applications that power the network, that empower the users to do stuff. Well, there's my stuff on the network. Next to that, you see a server. And that's one of the goals of the network is to allow these PCs to access the server, allow the PCs to access each other. Now, the PCs and the servers connect into the network using a network interface card. If you actually flip the computer around, you'll find a network interface card. A lot of people call it a NIC that is shoved in the back there, and that could be a wired connection. Most of the time, at least in today's world, it is where you have a wired Ethernet cable that you will run from that PC into a switch. Now, the funny thing about the network world is there's a place for everybody. I'm telling you, you may get into this and start realizing, hey, Cisco's cool, but I think that the cabling is much cooler. I'm not kidding. I was actually out at a site that I was setting up. It was a condominium complex, and they contracted me to come in and just set up the internet connection for all the condos to use. And they actually ran fiber optic cable to each of the condos. Now, fiber optic cable is glass. It takes specialized training to work with, and I mean, you're actually running glass tubing to each one of those condos that are capable of just amazing speeds. And I got there to set up the internet connection just as this gentleman was there installing this fiber optic cable, which I have no idea how to install the way he was doing it, and he was actually splicing two of them together. And it was amazing. He actually had in each one of his hands, he was holding it, cable that he was putting into this mystical box that had this little iPod screen on it. And he was kind of holding them together and moving it. And he could, the iPod screen, the small little screen, was like a zoomed in view of the cable. And he was putting it there and it goes, blink, stop, aligned, a little align thing started blinking on the screen. And he let go and pushed a button. And all of a sudden, you literally on the screen saw these white streaks, the laser. The laser was shooting in there like scalding. I don't know what it was doing, melting this glass together, splicing the cable. It took about 15 seconds. I'm sitting at the door almost having a heart attack watching this happen, and all of a sudden I will never forget this for the rest of my life. The thing said done, and it goes bing like a toaster oven. I'm thinking, what was that? Was that $100,000 piece of gear that just binged like a toaster oven? And so he opened it up, and wham, this cable that had once been two had now become one. It was spliced together. I was like, that is amazing. And this guy, that's all he does is run network cable. He doesn't know anything about the Cisco router or Cisco switch, anything like that. He just runs cable and makes a very good living at it. So it's kind of funny when I identify each one of these areas, I'm thinking, there's a career. There's a career. There's a career. This network, this road is so vast that there's, I'm telling you, just about something for everybody. What was I talking about? Network cards. So these PCs could be plugging in. Oh, network card. Yeah, I talked about that. The Ethernet cable. Most of the PCs will plug into the network using an Ethernet cable, and we'll talk more about the cabling standards in just a little bit. But that cable will run through the walls of the company into a network switch. Now, a switch is represented with an icon like that, and a switch is just a central meeting place for all of those things. It just has a bunch of ports for all the cables to plug into. You've probably seen one sometime in your life. You go to Best Buy, CompUSA, one of those kind of stores. They're on the shelves, and they just have ports for all the devices to plug in. Now, that switch is what allows local communication. Most people would call that a LAN, a local area network that allows people to communicate just among the local area as far as that Ethernet cable can reach. Now that switch eventually comes up here and connects to a router. Now, a router, its goal is to connect you outside of your LAN to other networks. Now that could be just another building that's right down the way from you, maybe 100 feet away, or and you've got another building over here that just you trenched cable under the ground. It could be, and most likely is, one of your links to the internet connection. This right here is considered a WAN, your wide area network connection, something that allows you to leave your network to connect to something that could be very far away. Now, the irony of a WAN link. When you say WAN, you think of, okay, there's that lightning bolt icon again. That's connecting me to the internet, and that must be very far away. But in reality, you essentially have this wall jack. You can see right here, the WAN is supplied by a service provider. You call up somebody like AT&T or Sprint or Quest or one of these big name service providers. They come in, install that wall jack, and if I were to draw this, here's the wall of your company, right? They put that little wall jack right there that you run your cable to your router, and they connect, under the ground, through your neighborhood or through your business's local area to their central office, which may not be that far away. It may be, less than a couple 100 feet, maybe less than a mile. And then that central office uplinks you to another building, to another building, to another building that eventually reaches you to the internet. Now, when you think of the internet, of course, a cloud is often used to describe it like it's this mystical cloud. But really, if you were to peel back that cloud and look inside of it, all you would see is this stuff. You would just see building upon building, router upon router, all connected together in this gigantic web. One of the names for the internet that people have commonly used is they say the internet is just a network of networks. That's all the cloud is. It's just everybody starting to link their network together into this giant grid. And there's so many links on that internet that no one place really sustains it. It just goes through everybody and kind of everybody goes through it. So we'll talk more about the internet later, but that's of course a common network that people connect to. So that service router comes and installs a wall jack. We run a cable from that wall jack into an interface of our router, and that allows us to access the internet. Now down below we have a wide area network. A lot of people use the internet as a backbone to connect to other offices around the world. Like maybe this headquarters office here is in Phoenix, Arizona, and then this office over here is in Russia, Moscow, Russia. And you can go through the internet because the internet already has all the groundwork laid, and you can actually reach that server in Russia. But when you're thinking about the internet, it's kind of scary to do that. When you communicate from Arizona to Russia, I mean, anybody could get that information and just kind of grab it off the internet and expose it and see exactly what you were sending. Security becomes a risk, and also sometimes just the internet can't get you there fast enough. You never know. Internet's like Forrest Gump. It's like a box of chocolates. You never know what you're going to get. Sometimes you may have a fast link to Russia, sometimes it may be slow because you're going through all these networks, and if one of those networks has a problem, that means you have a problem. So we also have a dedicated wide area network, which a lot of agencies use, that they could buy a private WAN link. Let me just write private, and horrible penmanship right there. But that's where we can have our router that we're paying somebody to maintain a link from us through their personal network, and maybe that's AT&T. You only stay on AT&T's network, or you only stay on Sprint's network. You go through their network and they link you up to Russia. Now, the benefit of doing that is you're guaranteed that you're going to get a certain level of service. You're always going to have, we'll say, a fast link up to Russia. You're always going to have a maintained link that really never goes down to Russia. But one of the problems that you run with that is cost. I mean, since you're paying a company to bring up a private line over to Russia, that's going to cost you a lot more money. So that's why some people prefer to use the internet to connect to their other offices. Other people prefer to use private service providers. The trend is slowly moving over to the internet. As of right now, more private links are used, but the trend is still there where the internet is slowly becoming the ultimate backbone. But these are all the pieces that tie a network together. Now let's turn our attention to the applications that use the network. And this is where a lot of the business perspective is going to come into things, where businesses employ this to get a return on investment. When you use your web browser, you're using a network. You open Internet Explorer or Firefox or whatever your favorite browser is, and you go to www.google.com, your computer is going to send a message out to Google saying, excuse me, I would like to have your web page. Now, Google's server gets that message and replies and says, well, here it is, and sends all the packets across the roads that we've built into our network, and poof, the Google web page appears on the screen. Now, the web browser, while we look at it and say, okay, well, that's great, you get to surf the internet, it's used for so much more. Within a company, you have an intranet rather than the internet. It's just like an internet sort of system inside of an organization that has private data, like corporate financial information, like information on shipping that is coming in and out of the company, like an employee roster, phone list, all of that, to where you can access your organization's own web pages from an internal web server and download all that into a web browser. Database applications, where you are one of many employees that, let me just take a common one, a help desk, where we'll say that you are a part of a help desk that takes support calls for Rolex watches when a Rolex watch breaks. Well, you get that support call in immediately on your screen. You can have it even does it automatically nowadays based on the caller ID, pop up a little window on your computer screen, and it says, the phone number that's calling. If they've called previously, it has all their records, and you can type in, the first name, the last name, the address, the da-da-da of all the Rolex watch issues and document the problem and so on. Click on the little save button, and immediately you send a transaction across the network to the database server that stores that for future reference. So when the gentleman who gets the Rolex calls back and says, hey, I'm still having the same issue, you can pull those records up from the database and get all that information displayed on the screen. Instant Messenger seems like something that people would be using just for fun, right? People have probably used that at home many years, but it's becoming quite the business application as well. Go back to the help desk issue. Somebody's calling in with the Rolex. If all your employees have an instant messenger client installed on their PCs, you can actually have this person who receives the call, that little user on the screen, jump in there and say, oh, the person is calling with the minute hand is not moving on his wristwatch, and he types that into the instant messenger, and it pops up on all the instant messenger clients that are part of their group. And immediately, Bob down the hall is like, oh, the minute hand issue. Well, yeah, you just gotta, fill in the blank. And they can chat via instant messenger, all while this guy's taking the support call, documenting all the information into the database application, all while surfing the internet at the same time. Just tried to combine all the applications in one breath. But that would be like an instant messenger communicating across that fabric of the network. Email has changed the world, wouldn't you say? I mean, it's one of those things that it's almost like an organization is lost without email now. No longer can they wait for the post service to deliver the contract or the message. You just want that information emailed over to you. That is a server-client system where a user sends an email that stays on a server somewhere until that other user opens their email client, which goes to that server and says, I would like my messages, and it's delivered to them, and they can see all the messages that have been sent across the network to them. Now, I know that last one, you've seen it, you're staring at it and going, come on. I'm telling you, it's a multi billion-dollar industry at this point. Online games is where you have the same style of system. I mean, everything kind of is based around, let me just clear off all my drawings on there so far. Everything's based around this server client infrastructure. This is, I've got to admit it, this is the only online game I've really play. It's called Counter-Strike, where you've got your little man and you are on a mission with other people around the world to take out a base of some sort, you know, and conquer, capture the flag, or whatever the case may be. But the idea behind it is everybody around the world is using this application and all streaming their moves, their shots, their whatever else may be involved in the game, picking up a weapon off the ground, all of that is being streamed to the server from this game that's running right here. And the server at the same time is streaming that information out to all of the other clients. So we'll just take this one right here. Has this little man running across the network, shooting all of these people defending the flag, right? Well, every time he clicks his mouse to shoot a bullet, that transmission goes up to the server, and the server sends across the network in real time that message to everybody else saying, bullet has been fired, these are the coordinates, and all of these PCs get that, process it, and, you know, maybe this guy now, you know, falls over because he got shot because the bullet targeted his exact coordinates on the screen. All of that is using a network streaming data across these roads that have been built to allow the communication between these devices. Regardless of the type of applications that you're running, there are three big considerations that we have to think about when we're managing the network that allows them to get there. The first, and I would say most likely, one of the biggest considerations for your applications is speed. You need to understand how speed in the network world works. We have these terms that are on the screen. You can see bit, byte, kilobyte, megabyte. I mean, I'm sure just about everybody listening to me right now has heard some of those terms before. If you have dealt with a computer, you probably have heard of a megabyte. Well, here's what they are. A byte, when you hear of a byte, that is like one character. When you go into Microsoft Word and type in W on your keyboard, that is 1 byte of information on the screen. You type in WAS to spell was. That is now 3 bytes of information sitting on your screen. A byte is really a character. Now, when you move up in size, you move into the world of kilobytes. And we follow this scale the whole way through. A kilobyte is 1,024 bytes. It's essentially, if we were to put it into something we could touch and feel, it would be one full page filled with characters without any margins on the page. It's about 1,024 characters, and that is a kilobyte. Now, same scale, you take 1,024 of those pages without any margins and fill them with characters and save them all to one place, and you have a megabyte of storage or a megabyte of space that's being used. Now we're getting into terms that we're familiar with, because most of the time when we think about memory on a computer, we think about it in terms of megabytes. Like a computer might have 128 megabytes of memory. It could have that many pages of documentation open in memory at the same time. Or, you know, nowadays it's almost, if you have a computer that has 128 megabytes, oh, you've got an old computer. We've actually moved into the gigabyte phase. Most of the time when you hear about gigabytes, you think about hard drive space. Like, I have a 100 or 300 gigabyte hard drive that is capable of storing 1,024 megabytes in every single gig, which holds 1,024 pages full of text, which holds, you know, individual bytes that are on those pages. All of those go into that size. Now you go above gigabyte and you move into, you know, 1,024 gigabytes is a terabyte, and go beyond that, you get into things, I think after that is the petabyte and then the exabyte, and after that it gets weird. I think you get into things like yettabytes and zettabytes and who knows? But all of this is moving larger. When we're thinking about speed on a network, the funny thing is we have to move smaller. And it ruins the whole scale, because we look at this, it's 1,024, 1,024. Anyone know how many bits are in a byte? 8. Now, what is a bit? I mean, when you think about a bit, you should be thinking about a 0 or a 1. It's the most foundational computer method of communicating that we have. I should even back up further than that. It's the way that computers work. Still to this day, we have computers that just process bits. You might think back to decades ago when computer programming classes consisted of people using punch cards, where they would literally punch these cards in with almost like hole punches to represent the on and off switches. If you didn't punch it, it was off. If you punched a hole through it, it was on. And that you would feed these big punch cards with all these holes in order into a processor and that would literally be your computer programming. You thought building roads was bad. Try that. I mean, that was the old way we used to process with computers. And the funny thing is we've moved, decades beyond that into Visual Basic and web coding and HTML and all of this stuff. But when you really boil it down, nothing's changed. We still work in ones and zeros on the computer. It's just that it looks much cleaner than it used to because we have all these pretty interfaces in front of it. Now, when we're working with information, every single byte takes 8 bits to create. So when you think of the letter W, you think of 1 byte, but the computer sees it as, 00101100. 8 bits. Now, I don't know if that's actually what W is. I almost guarantee you it's not, but that is how the computer sees it, is 8 bits. When you think, here's one that I would know. When you think about the number, we'll say 64, we think of it as 64. The computer sees it as 01000000. That is the binary version or bit form of the number 64. Now I know you might be thinking, well, that's 2 characters. Well, computers process numbers a little bit different than they do letters. So that's how a computer handles size. Now, how does this all tie into the network, you might be wondering? Well, the network is all rated at bits per second. That's the actual throughput that it could handle. So for example, if you've had a modem, you might remember, well, we'll say a modern modem might be 56 kilobits per second. That's one of the biggest mistakes that people make is they see that 56 kbps and they think, oh, that's kilobytes per second. Oh, no, it's not. That would mean if it was 56 kilobytes, notice the capital B, per second, that would mean that we could send 56 pages full of text without any margins in 1 second across that link. And that's actually not possible with a 56 kilobit per second link, because when you think 56 kilobytes per second, what do we have to do to convert that to kilobits per second? Well, look at that flow chart. 56 divided by 8 will tell you how many kilobits per second that is. So when you think about the network, all of the links are rated in terms that are probably a factor of 8 less than what we're used to dealing with on computers, bits per second. Now, when we move into the types of connection, usually our LAN links, pictured here, we've got computers plugged directly into a switch, will be speeds that are considered high speed. We'll say an old one might be 10 megabits per second would be a type of speed. Even though nowadays those network cards running at 10 megabits per second is considered slow, compared to our WAN links, notice these are our LAN links and these are our WAN links, that's a fairly fast connection. Modern computers and modern switches run at either 100 megabits per second or even 1,000 megabits per second. Most people call that a gigabit per second link. So those are the kinds of speeds we get used to on the LAN. Looking at that, you would say, wow, lots of speed. So I can send files back and forth between these computers. I can message between the computers. I could play an online game between those computers at extremely high speed connections. But when you look at the WAN and wide area networks, and you start thinking about links between your offices or links to the internet, usually those are lower speed connections. In some countries, 56K is a dream. They're like, hey, that's a great link if you've got 56K in some of the third world countries. So you're moving between links from 56 kilobits per second all the way through, who knows? Who knows, really? I mean, the WAN links of today are so varied in their speed, it's just silly. For example, you might have heard of a T1 line. A T1 line is considered a pretty decent connection. A couple years ago, it was considered really fast, but a T1 is 1.544 megabits per second. Just a small fraction of what would be considered today as a very slow LAN connection. And that's a link that would connect you up to the internet. But the T1 line, by the way, if you're looking at a T1 line to the internet, a modern day price would probably be about $300 a month. Wow, $300 a month for 1.544 megabits per second. That's a typical WAN link. As you move higher in speeds, I mean, WAN links today can get very fast, even moving, well, if you pay enough, you can get above 100 megabits per second, but at that rate, you're usually paying in the range of, maybe $80,000 a month for that kind of WAN link. So there's a lot of criteria that go into the WAN, but typically when we talk about the WAN, it's much slower. Now let's talk about the last two on here because I'm looking at my clock. I got to move along. Delay and availability. Applications, some of them have delay requirements. For example, we'll take the big one that's taking over the world by storm, voice over IP. You might have seen VoIP as a term in some of the magazines that are going across the computer industry. That's where phones plug into the network. Those have very specific delay requirements because when I speak, the sound that comes out of my mouth has to move across the network in a certain amount of time. Now, it's not the same thing as bandwidth. Bandwidth is how wide is the freeway, right? How many cars can go on that freeway at the same time? Delay is how fast are those cars moving? There's a lot of things that go into delay, like how far apart are the two locations that you're talking between, how congested in the link. All of those factors come in. Availability is how the network application, well, I'll just say how available the network roads are. If the network goes down and the road goes out, all application activity stops. For a business, that could mean the end of a business. Think of an eBay or an Amazon.com, a lot of online businesses. If the network goes out from under them, the entire business becomes unavailable. The last thing we'll talk about and wrap up with is network designs. A lot of people call these network topologies. What these are ways of designing your network or connecting your different devices on your network together. Now, these designs were from decades ago, when we had things like thin net cable, which was the cable that comes out of the back of your cable TV that connect our devices together. And we would actually run this thin net along one big strand called thick net and tap off all these individual PCs. That's what these circles are, individual PC connections. And that was known as a bus topology. And if any one of those, that cable broke, we would lose a segment of the network. If it snapped in half or lost connectivity, we would lose a group of devices. We also had rings. This is where you might have heard of a technology called token ring, where we'd have this token that spun around the network to each device and grabbed the data that was sending or receiving and delivered it to each device. But the topology that really took over the world was the star, which was where we have our switch in the middle and all the devices connected off the switch. And that was the topology of choice that ended up winning. But our networks don't look like lines with little circles plugged in. They look like this. We've got PCs and switches and routers and internets. And if you saw this diagram, what kind of topology would you identify this as? Well, you might look at it and go, it's a star, because we've got the PCs plugged into the switch in a star formation, and that's connected to another switch with the star formation. And some of you might look at it and go, well, it's a bus, because we have the switches that are tied together in a nice logical bus that all connect up to the router over here. And in actuality, it's both. Because we have star topologies coming off the switches and a bus topology connecting them together. So our modern networks today employ all kinds of those network designs and hybrids of them. You might also have a ring by attaching these switches together into a ring formation, and now you've got some redundancy between them. So if this link died between your switches, you still have successful communication that can happen. So those models, even though they were from networks of yesteryear, decades ago, are still employed today, even in our modern Ethernet world, to design our local area networks. And with that design view, that is the foundation of what a network is all about. So let's wrap up and hit the high points that we talked about. Number one, we define the function of the network. And putting it in its simplicity, the function of the network is to be the road. But trust me, you're not building roads as a career. It is the road that allows the applications to communicate, and there's a million considerations for how that road needs to work. So we looked at the pieces that builds that network. We saw the network interface cards that plug into the PCs, the cabling that ties it into the switch, the links that move from the switch to the router to the wide area network connecting up the WAN and the internet, the service provider connections. All those pieces tie together to be the road that ties your network to all of the different components and devices that attach. We then gave some examples of applications that use the network, from web surfing to FTP to online gaming. All kinds of things run across those roads, and it's our job to optimize the road to work best for the application our business is using. Finally, we wrapped up with a view of network designs. Now, those are some very simplistic designs, and we will get more complex as we go, but we looked at the bus, the ring, and the star topology and saw that today's networks really has a hybrid of all of the above. So with that, I hope this has been informative for you, and I'd like to thank you for viewing.